Hello and welcome back to NTMAU. This is Ken McCrate, and I'm going to go over this course, or at least this problem with you. This problem is problem number 282-39 if you're in my class. If you're not in my class, shame on you, you should be. And it can help you to learn math better than anybody else that's out there. So here we go. Without further ado, we're going to do the usual, and that is go for what we know. We know that we've got a distance from here to here of 1 inch, 173 and 6/10. We also know that we've got a distance from here to here that's exactly the same size, right? And guess what? This distance from here to here is the same size. Why? Why are all these the same? Well, it's simple. This is a radius all the way around. So this distance from the center point to the tangent point, the center point to a tangent point, the center point to a tangent point is 1 inch, 176 and 3/10. This being a tangent point there, this being a tangent point there, and that being a tangent point right there. Remember, anywhere where a ball or a radius touches a surface, that becomes the tangent point. Now, what does that mean? That means 90 degrees. So it's at 90 degrees somewhere in that angle, and that's easy enough for us to figure out from there. So let's put a few numbers in there, and then we'll move forward. Okay, so I just put that number in there for you, just so that you can kind of see that that's what we have for here, and of course it's going to be the same here, and it'll be the same there. Now, again, we're going to go for what we know. We know that we've got 52 degrees right here, right? So if that's 52 degrees, and I had an arc that came all the way around from this point here, all the way around to here, that would be 180 degrees, wouldn't it? Because that's half of a circle. Half of a circle. If we went all the way around, it would be 360 degrees. But because we went from this point to this point, halfway around a circle is 180 degrees. So what we want to do is we want to take 180, and we want to subtract 52 degrees from it. Now, I don't know if this is going to help me or not, but this is a standard procedure that you should always do whenever you're going to solve for any problem, and you're looking for angles, okay, or you're looking for the solution to the angles. Now, I have all the angles on there already for you, but if you're in my class, you didn't have these on there before, so this is there to help you. So we're going to take 180 and we're going to subtract 52 degrees from it. So that's simple enough. 2 divided by 128 equals 64 degrees. That's what that is inside here, okay? Now, again, do I need that? I don't know, but I want to put it in there just in case I do. And we also know that this is going to be 64 degrees here. Why? Because it's going to be the combination of both these to equal this. Well, guess what that gives us? That gives us this here, because opposite and interior angles are congruent to each other, or equal to each other. So how do we get that? Well, let's take a look at that. So what we see is we've got this line coming down like this, and this line coming like this. So whatever we have inside here for this angle, this one's projected at the same. So A2 equals 64 degrees. And guess what else we have? We have A1. A1 is going to be the total of this angle here. That means the balance of the 180. Remember when we were looking for the 180? Or we had the 180, and we subtracted 52 degrees from it because it told us that that's what the 52 degrees is there. And we came up with 128. So A1 equals 128. And we know that A2 equals 64. All right, so we've got that much done. That's the easy stuff. So let's go for some of the stuff that's a little bit more difficult, and it's going to mean that we've got to do a little bit of trig. So to do a little bit of trig, let's go ahead and figure this out. The first thing that I want to do is I know that I've got 64 degrees inside here. You can work with this side if you want. And you know that you've got this distance here. What's this distance here? Do you remember? It's 1 inch, 176 3/10 because we came off the center point to here. So what are we looking for on this? We're looking for the, under this case, if we use this angle right here, we're looking for the adjacent side. That's going to be this surface right here, okay? The distance from here to here. Why do I need that? I need that because what I'm going to do is I'm going to take 1 inch, 750 thousandths, and I'm going to subtract this from it. Am I going too fast? I'll write it down for you then. 1 inch, 750, that's the distance that they tell us, right here, minus whatever the heck I come up with here. So I'm going to just drop that right there. And I don't know what that is yet, so I'm going to just put that little marker there. How am I going to get that, though? Well, I'm looking for the adjacent side. Well, if you remember the old formula, and I'll write it down for you. So what do we have? O, hell, opposite over hypotenuse, another hour, adjacent over hypotenuse, of arithmetic, opposite over adjacent. Remember, opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. Oh, hell, another hour of arithmetic. And these follow in the order of the function keys that are on your calculator, in the calculator order, reading from left to right, as we normally do, which is sine, cosine, and tangent. So all we have to do is match this. Okay, so what are we looking for? We're looking for the adjacent side. Well, there's an adjacent at the top. The one on the top is the one you're looking for. The one on the bottom is the one that you have. Do I have this here? Do I have this side here? I don't. That is the hypotenuse, isn't it? Do I have this side here? I do have this side here, but that doesn't match this here. I have to have the adjacent. So remember, the way this formula works is the one on the top is the one that you're looking for. The one on the bottom is the one that you have. That means that you're going to have to use secondary functions, which means the cosecant, the secant, and the cotangent. Or do another little trick. Do you know what this angle is here? You sure do. Well, not right off the top, but pretty close, because you know that this is 64 degrees inside here. If this is 64 degrees and that's 90 there, all we're going to do is take 90 minus 64, and that's going to give us 6, and that's going to give us 20, right? So that means that that angle right there is 26 degrees. If that's 26 degrees, now I'm going to be looking for this side over here still. Okay, nothing's different. I'm still going to be looking for this surface. What is this surface called if this is the angle that I have? Well, it's called the opposite side because it's opposite the angle that I have. Okay, so opposite. Well, I have an opposite right there, and I have an opposite over here. Now all I got to do is match the bottom with the one that I know. Do I know what the hypotenuse of this angle is? Well, we've been there before. No, I don't. This is the hypotenuse. I don't know what that size is. So that one's out. That's not going to be the one. Do I know what the adjacent side is? You betcha. I know what this distance is here because this is the adjacent side right here. Hey, we can use that formula then. So all I have to do is plug into my calculator 1.176 3/10. Okay, so 1.1763. Wish I could write better, but sorry, folks. You could get the idea. And I'm going to figure out the tangent of 26 degrees. So I'm going to plug in 26 degrees and then hit tangent, and then it equals, and that'll tell you what this distance is here. Okay? That's all you have to do. You could put in 26 first if you'd like, hit the tangent key, and then multiply it times 1.1763. That works just as well. What you're going to come up with is 573 7/10. That's what this distance is right here. So let's bring this right here like this. Okay? 573 7/10. So then, Now to solve for this side, this distance right here, and let me grab a different color so we don't get you all mixed up here. I'm going to stay with black, I think. I'm going to draw this distance down from here down to here. Okay. And I know that I've got this over here. And they're sharing the same plane, so they have to be equal to each other. Okay. So this is the angle that I'm looking for right now. This black one. I know that I'm going to have a 90 degrees in here because that stays the same. What is this distance here? It's going to be 1 inch, 750 thousandths. Minus the 573 and 7/10. Write that down. Whoops, didn't come out. So doing the math on that, we're going to get 1 inch, 176 and 2/10. And you can put the 8 on there if you want. Or you could carry this over and make this 1 inch, 176 and 3/10. That works too. Okay, so what are we looking for? Well, we're looking for this angle, this inclusive angle. The angle that, I shouldn't say inclusive, sorry about that, it's not an inclusive angle. We're looking for this angle right here. So what that means is if I can solve for this angle here, this one's going to be the same because I have a surface that's the same length as the other one and it shares the same plane. Why? Because I've got this radius here, I've got this radius here, that's both the same, and they share the same plane. Okay? So all I want to do now is solve for this angle right here. And how am I going to do that? Well, the same way as we did this up here, except that it's a little bit different. In that, we know that we've got a side. The side that we have is 1.1763. So let me put it in that color. And if we get the 1.1763 here, well, these two numbers being the same, what does that tell you? That tells you that anytime you have two sides that are exactly the same and they share the same plane, it's going to be a 45 degrees. So that's 45 degrees inside there. So you don't have to do the trig on that. It's just common sense. Okay? The length is the same as the length. It's the same as the length. And it shares the same plane. This is a 45 degrees inside here. So A3 was simple enough because we came up with 45 degrees. Now, I want you to write down all of these that you see here, all these numbers, because what we're going to do is now we're going to solve for this 52 degrees inside here so that we could come up with this angle over here. Also, I want to go with a problem that would give us a whole bunch of other information, but maybe we don't have this 52 degrees. Can I still solve for it? Well, you know, that's a good question. Most likely, yes, you can. You can still solve for this, but, well, maybe we'll leave that one for the next time. But let's go ahead and solve for this dimension right now, this one right here. How do we know what this is going to be? How do we know what dimension 1 is going to be? Well, we know that we've got 625 thousandths here. Kind of hard to see, but you've got 625 thousandths here. You have 1 inch, 750 thousandths here. And you have 3 inches, 875 thousandths here. That's the total length. So if we went and we created this, we know that we've got 3.875 and what I'm trying to do now, team, is solve for this length right from here up to here. Except let's kind of make that a straight line. So let's solve for it from here to here. Nice straight line, okay? That means right from where this left off, right here, right where it left off on this green surface, okay? make this a little bit closer to being exact. How's that? It's off a little bit. You get the idea. So right from here to this distance here, this is the unknown. So we're taking 3.875 thousandths. That's the distance from this very, very bottom to the very top. So right here, minus 625 thousandths minus 1 inch 750. And that'll tell us what's left over here. Okay, so let's go ahead and do that. Okay, so doing this, 3 inches, 875 minus 625 minus 1.750 equals 1.5. Now, what do you have? You have an adjacent side here, and you have an angle. The angle that you have here is this 52 degrees that hasn't changed. Okay, what does that make this side right here? It makes it the adjacent side because it's next to the point where the angle is given. Okay, so if it's next to the point where the angle is given, it's adjacent side. What are you looking for? You're looking for the opposite side. Well, now we can use the tangent. So we know that we are looking for the one on top is the one you're looking for, which is the opposite. Okay, and let me grab a pen. Didn't want to write before. I still don't have a pen. Opposite's what we're looking for. The one on top is the one you're looking for. The one on the bottom is the one that you have, and you have this distance right here, the adjacent side. Okay, so we're using this. We're using this formula right here. And the adjacent is going to be 1.5. And we know that we have the tangent of 52 degrees. So all you got to do, this is the tangent, okay? This equals the tangent. Opposite over adjacent equals tangent, just like what we have here, okay? Let's go ahead and do the math. First thing you want to do, take 52, plug that in, hit your tangent key. You're going to come up with 1.27994. Whoops, that's a crummy 2. Times 1.5. And that's your answer for that up there. That equals 1.91999. Don't get mixed up, that is a 9. Lousy number writing here, folks, but I'm doing this with the mouse, okay? 1.9199, and it actually has a 1 after that, okay? So now can you solve for this? You sure can. Just take 3 inches and subtract 1.9199 from it, and that'll tell you what that is. That's all of them, okay? That's everything that you need to know. Once you know this distance, all you have to do is take this distance and add this ball diameter onto it by adding this and this. 1.1763 plus 1.1763, because you'll have this, and that gives you X. All right? That should do it, guys. All right, so let's go ahead and finish this out. So we have 3 inches minus 1.9199. That equals, let's see, so what you got is 1 inch, 0.01, 1 inch, 0.80 and 1/10 minus, no, I'm sorry, plus, because you're going to add this on there, plus 1.1763, that's this radius from here to here, plus 1.1763, that's the radius from here to here, same radius, okay, same deal, just what we had here. You're adding them together, you know what this distance is here. You're going to add this one, you're going to add this one, and you're going to come up with 3 inches, 432 7/10. And that's it, folks. That's all she wrote. That's all the numbers that you have in there. Of course, if you have a problem, send me an email. We'll get it squared away. I'm always here to help you. Thanks, and have a great day. Take care.